Problem number 14. At each point on the surface of the cube, as shown in the figure, the electric field is parallel to the z-axis. The length of each edge of the cube is 4 meters. On the top face of the cube, the field is E vector equal to minus 34 k cap Newton per coulomb. And on the bottom face, it is E vector which is equal to plus 20 k cap Newton per coulomb. Determine the net charge contained within the cube. So let's see the given figure. So you have the cube and the axes are mentioned here. So this is the positive direction of the z-axis. This is the positive direction of the x-axis. This is y-axis. And they clearly mention the electric field is parallel to the z-axis. That means your electric field is exactly entering like this. Am I right? So parallel means parallel to the z-axis means the lines are parallel to z-axis. So when you have the electric field parallel, the electric field lines entering only the top face as well as the bottom face. That bottom face is hidden here. So when you have the electric field parallel to the direction of the z-axis, that means your electric field will enter only two faces of the cube because the cube has 6 sides. So in this case, if your electric field is parallel to the z-axis, it will enter only the top face as well as the bottom face. Remaining 4 phases, there is no electric field lines entering through the phase. And also they clearly mention the electric field lines for the top side. You can see the field lines are moving to the negative direction of the cake. That means negative direction of the z-axis. That means in the top phase, your field lines are going like this. How we can say? You can see the value negative of k cap. That means this is a positive of z-axis. That means this is the negative of z-axis. That means the negative of z-axis is given by minus k cap, right? So that's the reason I told you your electric field lines are moving downward direction through the top surface. That means your field lines are entering the top face. Likewise, in the bottom face, you can see the electric field lines are moving to the positive direction of the z-axis. So this is the hidden face. So your electrical field lines from the bottom face, it is moving like this. Why? Because of the positive direction of the k cap. So in the top face, the field lines are downward direction, and in the bottom face, the field lines are upward direction. How we can say? By means of this k cap, minus k cap, here plus k cap. Clear? So now we have to find the value of the charge. So what is the formula for the flux? The formula for the flux, we have phi, which is equal to electric field multiplied by area, and also we have electric field which is equal to charge enclosed over epsilon naught. So now we are going to find the value of the Q. So for that I need the flux. So what I'm going to do, first I'm going to apply this rule to get the answer for the flux, and then once I find, I can easily find the value of the charge which is inside this cube, right? So let's start with the first one. So I have to apply this phi which is equal to EA for the top face as well as the bottom face. So that means the net flux which is equal to the flux from the top plus the flux from the bottom. And the flux from the top, the formula is electric field multiplied by area. And also the flux from the bottom is also electric field multiplied by area. But the sign is very, very important. So here I mentioned positive sign, but we have to fix the sign based on the direction of the electric field lines. In the theory we studied, when the electric field lines are entering the area, it takes the value. That means the flux value is negative. Am I right? So you can see here the field lines are entering the top phase. So when the field lines are entering the top phase, that means the flux through this area is negative. So what I have to do? I have to put negative here. Likewise for the bottom, again the field lines are entering the bottom. Again, if the field lines are entering the bottom face, that means bottom surface of the face of the cube, it also negative. So we have to put negative. That's the reason we fix the negative. But the general formula net is nothing but we have to just add these two fluxes. But concept here, we have to fix the sign because the flux has positive and the negative value. When the field lines are entering, it takes the value of negative. When the field lines are going out of the phase, it takes the value of positive. So here in the top phase, the field lines are entering, and the bottom phase also the field lines are entering. So that's the reason I fixed the negative sign here. Now we have to fix the value of the electric field from the top. So better I can use the suffix T and here suffix B. Why? Because the values are different. So let's substitute the value minus the electric field from the top here is 34. Don't put minus here because this minus is the direction of the field. So already we fixed the information. So here the electric field value is 34 multiplied by area. So here the edge length is 4. So if the edge length is 4 means, if the edge length is 4 means the area formula is nothing but the length multiplied by width. So 4 multiplied by 4, you'll get the answer for area. So I have to multiply 4 with, so 4 square. Likewise here, minus the electric field from the bottom here is 20. So 20 multiplied by area, which is also a 4 square. So let's see what is the answer here. Minus 34 multiplied by 16 multiply, so minus 20 multiplied by 4 square, which is 16. So the answer here I got for the flux net, which is minus 864. What's the unit? The unit for the flux is Newton meter square over Coulomb. So this is our net flux. Once we find the net flux, we can easily find the charge. So net flux, which is equal to the charge enclosed into the surface divided by epsilon naught. Therefore, Q, which is equal to the net flux multiplied by epsilon naught. So here the net flux is minus 864 and then multiplied by the constant 8.85 multiplied 10 to the power of minus 12. So when I multiply this minus 864 with the 8.85 10 to the power of minus 12, I got minus Q, which is equal to minus 7.65 multiplied 10 to the power of minus 9 Coulomb. So here I got this answer. Minus 8.86, 85 multiplied 10 to the power of minus 12. So this is the answer for this question. That's it. Thank you.